Hello students, this is section 10-1, naming polygons. A polygon is a plane figure formed by a finite number of segments. In a convex polygon, all of the diagonals lie in the interior. A regular polygon is a convex polygon that is both equilateral and equiangular. In a concave polygon, any point of a diagonal lies in the exterior. Some of the basic polygons that we've discussed thus far, triangles in particular, of course, those are three-sided polygons. We've kind of graduated up to quadrilaterals, and then as we've kind of seen off and on, we've discussed pentagons a bit, but also hexagons, and then we can kind of graduate up from there. And we're going to take a look at a whole variety of both convex and concave polygons. So to start our discussion, here's the example. It says match each term with the appropriate letter from the box below. Some letters may be used more than once. Okay. So number one, concave polygon. So again, if you look up above, it says in a concave polygon, any point of a diagonal lies in the exterior. So with the convex polygon kind of being the as we've seen, the more kind of fundamental type of polygon with triangles starting our discussion there. Convex polygons actually take shape. I'll start with this simple three-sided triangle, of course. This is convex because there are no points of which, if I were to, this is the kind of analogy for the day here. If I were to kind of wrap a rubber band or try to wrap a rubber band around it, the rubber band would be stretched out in such a way that it would not have any kind of gaps between it and the side in particular that we're trying to wrap around it. Now, and that's convex, but as far as concave, let's say we're going to have to crank this up to an extra side, something like this. So this is a four-sided polygon. If I were to try to wrap a rubber band around this concave polygon, it would look something like this. So the rubber band would stretch out in such a way where there would be a gap in between these two kind of, I guess you could say, aspects. The point of which you got this red side meeting with the other red side, there's a gap in between. So that's concave. So for number one, a concave polygon, they say is letter C. What is letter C? Okay, R, F, A, N, T. So if you look at the picture down below, R, F, A, N, T, and again, we'll use our analogy to help frame our understanding. If I were to imagine wrapping a rubber band around this, it wouldn't technically touch side NT nor side TR, not completely. I mean, if you try to stretch this out in such a way where it does touch the other three sides, it wouldn't then touch those other two. And of course, as far as labeling, R, F, A, N, T, those letters are in the order of which, if you start at R, circle around, go to F, A, N, T. Now, if you picked another letter to start with and you go in the other direction, that's fine. Just go in order, as we've seen in the past. Number two, a convex polygon, they say, is letter A, particularly B, F. A lot of letters, B, F, X, K, H, and W. So, of course, that's the picture that you see just above it. That particular polygon is convex. Again, if you were to try to maybe wrap the rubber band around it, so to speak, it would essentially touch every side. All right, number three, diagonal, they say is E. So for that answer, we can see BX. In the picture above, you see BX connecting this vertex at point B to that vertex at point X. The diagonal, as they suggest, right here, all the diagonals lie in the interior. So certainly that diagonal is inside the polygon. Number four, hexagon, and they say here letter A. yet again, and well, that's because there are 1, 2, 3, 4, 5, 6 sides to that polygon. Number 5, pentagon, and that would be letter C, RF, A, and T, and there are, of course, 5 sides to that particular polygon. Let's see, number 6, a side. So letter D would be the answer to that, they say, and that's TR. And in the context of the second polygon down below, TR would be a perfectly good example of a side. Okay, so we didn't use B, we didn't use F. Letter B is, again, the arrangement of letters for, well, they say AF, N, and they jump to N. If you were to use those letters, you couldn't technically jump to N. You'd have to say AF, R, T, N. So that's why letter B wasn't used. And then letter F really had no utilization because R, although it is a point, in other words, also a vertex on that second polygon, it wasn't asked. Let's move on. Classify each polygon by A, the number of sides, B as regular or non-regular or not regular, same thing, and C as convex or concave. Okay, so number 1, for part A, if you count the number of sides, we've got 1, 2, 3, 4, 5, 6, 7 sides. I did actually stop at 6 sides earlier when I was discussing, the names of polygons. We go from a triangle, quadrilateral, pentagon, hexagon, and then this, because it's 7 sides, we say heptagon. Okay. Regularity, that's something that has to do with whether or not it's both equilateral and equiangular, as we saw up top. I'll underline that for you. For this particular picture or depiction, we are not looking at sides nor angles that are congruent, so it's not regular. Keep in mind something that would be regular. Simply, you can maybe imagine an equilateral triangle, which we've dealt with in the past, but also possibly a square. There are certainly other polygons that are regular beyond those two, but in this particular case, this 7-sided polygon is not regular. Last but not least, part C. I'll use the analogy again to help us understand and frame what this is, particularly where if it were wrapped around, the rubber band, so to speak, would touch every side, so that would be convex. Number 2, we start off with part A. The number of sides, we've got 1, 2, 3, 4, 5, 6. So this is a hexagon. Part B, regular and non-regular, it again doesn't look like all the sides are the same measure, so not regular, nor are the angles. And then last but not least, part C, again, trying to wrap that rubber band around. No, it's not going to touch every side, so to speak, so concave. Number 3, there are 4 sides to this. Generally, we'll say quadrilateral. It does appear to be regular. And because it's regular, I can go as far as to also call this a square. And then lastly, convex, because again, the rubber band trick does work in which it touches every side. Okay, number 4, this is for part A, 1, 2, 3, 4-sided, so quadrilateral. For part B, we can see here that all the sides are not technically congruent, so it is not regular or non-regular. And then part C, certainly again the concave aspect, thanks to the rubber band trick, is what we're seeing here. So for number 5, we've got 5 sides, 1, 2, 3, 4, 5. So pentagon. Are all the sides congruent? Actually, yes. And I'm going to go back to number 3 and label accordingly because all the sides and all the angles are congruent, as well as number 5 here. Go ahead and mark them up as congruent. That's a nice way to do that. And then also so the angles. Now the problem that we did on number 3, the picture we saw there on number 3, with that problem, because it's a square, we have 4 right angles. Number 5, we're going to mark them up congruent. And later we'll find what the values of those angles are, the measures of those angles, the values of which relate to formulaically, something we can kind of easily see and decipher. So part C, concave or convex. Again, we're going to see here that the rubber band trick works in convex, so convex. Last but not least, there are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. This is called a dodecagon. Okay. No, not all the sides are congruent, so this is not regular, nor are all the angles congruent. So again, not regular for those 2 reasons. And then part C,